Hey everyone, welcome back. In the last two videos, we have solved some problems based on vector STL containers. Today we are going to solve more problems. In the last videos, we have seen sum of elements. In this, we were adding all the values of the array, and in the second question, we were reversing the vector where our vector was 10, 20, 30, 40, and we have to reverse it to the 40, 30, 20 and 10. For this we used inbuilt function. Also we used custom reverse. Then in third questions we have seen count even numbers. So in this question we have to count how many even numbers were available in the array, and our last question was find maximum and minimum. So we have to print two things, max value and min value. Our question is find the element x in the array. So our array size is 7 and our value of x is 7, and this is our array. So you have to find that this 7 is present or not in this array. So in this array our 7 is present, so it will return true. Let's take another example. Let's take n equals to 5, x equals to 2, array of 1 3 7 4 5. Okay, so in this case you can see 2 is not available, so it will return false, right? So it is similar to our previous questions. So we have to compare all the values with the x itself, right? So we have to iterate over them, so we will use loops. Okay, now we have to compare at I equals to 0. We will compare 5 equals to 7. No. I equals to 1. 4 equals to 7. No. I equals to 2. 3 equals to 7. No. I equals to 3. 2 equals to 7. No. I equals to 4. 7 equals to 7. True. So as long as we find our value, we will break our loop from here, because we already found our element, so we don't have to go till the end. This technique is called linear search. Means we are iterating over all the values of the array and searching a value in that array. So it is called linear search. And what will be the time complexity? It will be big of n, right? Because we are iterating over all the elements in the worst case. Okay, in average case it can be big of 1, right? It may happen you will be able to find your value at the first index every time. In this case it will be big of 1, but we will always take worst case, so our time complexity will be big of n. Okay, so let's write the code. Okay, so we will take int n, which is size of vector or array. Also let's take x, which is going to be element which we have to find. Then let's take input here. Okay, so we will declare n x, then we will take input of nx, then we will declare our vector, then we will take input in vector. After this we use one more loop for int I equal to 0, I less than n, I plus. Then we will compare. If our current value is equals to x, then we can write found, else we can say not found. Okay, so let's run it. So now we have to give two input first, the size of array, also the value we have to find. So let's take 2, right? Then we have to give the array value 1 3. Let's, okay, there is one problem. The problem is at every value the if else condition is running, right? So if the value is not found, it will print not found. Then our value of I increase, then it again printed not found. Then at index number 2 it got the value, so it printed found. Then at 3 and it didn't find, so it is printing again not found. But we have to print only one time, not the number of times, right? Because in this case it is only for 5 times, but if you write a loop for 50 times, 100 times or 1000 times, you are not going to print all of them. So for this you have to declare one variable boolean, we can say flag. It was initially 0, right? Means we are considering there is no value in the array. Let's move else. Then here we can write if we found our value, we make this flag 1. That means it is kind of switch. 0 means off, 1 means on, right? So 1 means we got a value. And let's say we found our value at the index number 2. So after index number 2 we don't have to go to 3 4. So there is one statement in C++ which is break, which will break the loop from that index. Means at index 2 we got a value 2, so a flag become 1, then it will break loop from that index, then it will come out of the loop. Then here we can write if flag equals to 1, then we can say found, else we can say not found, right? Okay, let's copy paste here. Okay, it is printing found. Okay, let's run it again. Let's remove 2, let's add 5, so it is printing found. Okay, if you write this if else condition in the loop itself, it will print for every values itself. Okay, let's solve one more problem. So our problem is left rotate array by one place. Means this is our array size and this is our array, so we have to rotate the array to the left by one place. So our array will become 3 4 5 1 2, right? 3 will come here, 4 5 1, and 2 will go to the end, right? So basically we have to only pick one element, so we can create a new array, right? And place our value by one index. So we have this array, so we will create a new vector, right? And we will iterate over this vector. So now we have to pick this value from front and put at the back. So we know the index number of here and index number of the last. So before that we have to shift all the values to the left. So here you can see this is at index number 1 2 3 4 and this is at index number 0 1 2 3 4. So the index number is got decreasing. Here it was 1, here it is 0, here it is 2, here it is 1, here it is 3, here it is 2. So as we are shifting our value to the left, the index number is got decreased by 1, right? So we can use like this, right? So we will run our loop from 1 from here, because this value will go to the end. So we will run our loop from here and we will insert at this index will be 0. So our expression will be v will be our new array. Okay, let's give another name, new array. So it is starting from 0, so we'll be assigning like this. When we are at index 1, here index should be 0. When we are index at 2, here index should be 1, right? So it is 1 minus. So if we are writing I here, we can write here I minus 1. So in this way our value will got insert like this. Okay, now we have to insert our last value. So to insert our last value, so our last value will be at the n minus 1 and we have to pick it from the front, right? So our value here will be 2. Okay, so in this way we can, okay, let's write a pseudo code here. So we first write our for loop which is running 0 to n I plus plus. Okay, and we created a new vector, new arr. Okay, you can take a size of n, then new arr of I minus 1 of arr of I, right? Because we are starting from 1, not from 0. So if we are at 1, there should be at 0, so we are writing I minus 1. Now after running our loop, now we have to insert first value also. So for first value we will write n minus 1, right? It is at the at index and this one is at the 0 index. So this is our code for this problem. Now what is the time and space complexity? So we are running the loop from 1 to n, right? So it will be, and because here 1 to n, then 0 we are picking it up from here, so overall time complexity will be big of 1. Now what is the space complexity? It will be big of n, because we are using new array to solve this problem, right? So how we can make this space complexity big of 1? To make this big of 1, we have to remove this vector, right? So we have to only place one value to the end and all the values will got shifted to the left, right? Okay, let's take example. Okay, this is our array. We have to only place here and all the values will got shifted here, right? So instead of using new array, we can declare a variable x where we can store our first value in the x, right? Then after this we can shift our data, right? So we can use same array to reassign the values, and after shifting our values we can write array of n minus 1 equals to x, right? X is containing our 2, so it will come here. So instead of creating new vector to store our all the values, we just have to create one variable to store one value, and all the values will got shifted to the left, and then the variable be created to store one value be inserted at the back of the array. So now what will be the time complexity? It will still be n, but space complexity will become 1, because we are not using any extra vector or array, and the variable will only take big of 1. So our overall space complexity will be big of 1 and time complexity will be big of n. Okay, let's write the code for both of the methods. Okay, let's remove this, let's remove the flag, let's remove x also. Now we have a vector. Okay, let's create one more vector. Okay, I can create here new v of size n. Okay, so in a single data type I can declare multiple vector arrays strings. Now let's remove this. Okay, so we have v of n where we taking input, and new v is for storing our new array. Okay, so we will write new v of I minus 1 equal to v of I, and I will start from 1. Okay, now after doing this we have to insert one value from the front of the v to the back of the new v. So new v is at n minus 1 and v is at a 0. Okay, now let's print for auto it of new v out. That's it. Our array size is 5, then value will be 7. I can write here random value. Here you can see our 7 is at the back and our 8963 is shifted by 1 index. Okay, so this one is taking time complexity of n and space complexity of n. So let's make some changes. Instead of creating new vector, we will use same vector. Now before shifting our value, we have to store first value, because if we shift our values without storing first value, the first value will be override by other values and it will be lost. So we first declare int x equals to v of 0. We will first store our first value, then we can shift, then we have to insert x to the end of the vector. Okay, let's run this code. Let's remove. Okay, this will be v. Here you can see it is giving me the same output, and this time our space complexity will is big of 1. Okay, that's it for the arrays or vector types problem. In the next video I'm going to take one more STL containers and we are going to use that container to solve more problems. Until then, thank you everyone, have a nice